Hello everyone. So today we are going to discuss Leetcode 3208 Alternating Groups Part 2. So in this question, you are given a circle of red and blue tiles and you are given an array of integers color and another integer k. The color of the I tile is represented with colors of I. So we have got either red or blue tiles and these colors are represented with the value of colors of I. If colors of I is 0, then it's a red tile. The ith tile is red. And if colors of I is equals to 1, then it means the ith tile is blue. Now, this is a definition of alternating group. An alternating group is every k contiguous tiles in the circle with alternating colors. So basically, if it's a red, blue, red, blue, red, okay, and suppose the value of k is 5, then it's an alternating group of k tiles, or it could be blue, red, blue, red, blue. So this is what an alternating group is. And obviously, since the colors are represented with 0 and 1, so it could be 0 1 0 1 0, or it could be 1 0 1 0 1. That's an alternating group with k equals to 5 because it's a group of size k. Okay, that's what an alternating group is. So we have to return the number of alternating groups that are possible. And also that it's a very important note is that the first and the last tiles are considered to be next to each other. Since it's a circular tile, so they are considered next to each other. Let's see an example to understand the question more thoroughly. So over here, the colors array is given as this. So it's a red, blue, red, red, blue, red, blue. Yeah, it can be represented on circular tile over here. It's the depiction of the array, and here they need the value of k as 6. It means I need an alternating group with 6 tiles in it. So let's see if I can find an alternating group with 6 tiles in it. So if we focus on the image over here, we have to see the alternating groups: red, blue, red, red. Again, the alternating groups is broken down because two reds come with each other, right? And we needed the value of k is 6. Yeah, but we got only 3: red, blue, red. The alternating nature broke down over here because two reds came in together. Now let's see if we can find any other alternating group. So if we see over here, red, blue, red, blue, red, blue, red. So it's a good alternating group from here to here, right? So how many tiles are there? 1, 2, 3, 4, 5, 6, 7. But do we need 7? No, we need only 6 tiles. So an alternating group of 6 tiles can be considered as this, right? So we have got one alternating group. Is there any other alternating group? Sure, let's start with counting over here. So it's 1, 2, 3, 4, 5, 6. Again, 6 alternating group, which is different than the previous one because the previous one included this as the alternating group, right? The groups can be overlapping. Okay, so there are two alternating groups that are possible, and that's why the output is 2. And that's how they have explained it as well. You can take this, they have highlighted the colors, and you can take this. So the first approach that comes to mind is the brute force. So we can iterate over the indexes of the array and check if it is possible, if an alternating group can be formed starting from index I. If it can be formed, we increment the count, we increment the answer, and obviously we will initialize our answer with 0. So for every index, we'll check if an alternating group of size k can be formed. Now, how do we write this? So this is going to be our isAlternating function. It takes in parameter the index from where we have to start and the size of the alternating group that we are required to form. So we will start looping from the I plus 1th index and we will go up to a size of k, and we will check if the consecutive elements are equal, then we will simply return false. However, if none of the consecutive elements are equal, then we will simply return true. And since the tiles is in a circular fashion, so we are using a modulo sign so that we can jump back to the first element if we exceed our last element. So in case j minus 1 is equals to n and we are assuming a zero based indexing, since colors of n doesn't exist, then n modulo n will give you 0 and it will throw you back to the first element. So use of modulo sign is very important over here so that we can iterate the array in a circular fashion. And that's how we create the is alternating check. And that's how this brute force works. If an alternating array is possible starting from index I, we will just increment the answer. And finally, we will simply return answer. Now, let's analyze the time complexity of this code. So obviously, this code runs for n time. So, this loop takes O of n time. Now, is alternating function again runs a loop that runs for k times, right? It starts from I and it goes till I plus k. So it runs for k time. Yeah. So this runs for n time and this takes a time complexity of k. So the overall time complexity of this code is n times k. Now, the value of n is around 10 power 6 and the value of k is also less than or equal to n. So, it goes up until 10 power 12. So, obviously, this solution will give us time limit exceeded. So, that's why this solution will not be accepted. Let's move ahead and think of a better approach. Now, before directly jumping to the better approach, let's approach this problem in this manner. We'll first try and find out if there exists an alternating group of size k. How do we check if there exists an alternating group of size k? Let's first think, is there a group of size k? If there is, how do we analyze that? So you will say, okay, it's simple. We can check if there exists a group of size k just by looping. I'll say, okay. So obviously we will first of all initialize our count variable that will count the number of element in the group. So initially we will initialize it with 0 and then we will start looping from 1 to n. Okay. If two consecutive elements are not equal, it means this is what we want in our alternating array, right? It means we will increment the count. And if the value of count becomes equals to k, then we will simply say, yeah, there exists a size of k. What if the consecutive element become equal? What if this condition is not satisfied? Then we will reverse our count back to 0, right? This is the first thing that comes to mind. Now let's dry run and check if it works. So we will start looping from the first index, right? So that colors of I minus 1 is this index over here. Okay. Now over here, the value of I is over here. If colors of I minus 1 is not equals to colors of I, 1 is not equals to 0, then we will increment the count. So the value of count over here is equals to 1. Should it be 1 or should it be 2? Because I am having an alternating group of size 2, right? I am having an alternating group of size 2, but the count will be incremented to 1 only. So it means we should initialize our count with 1. That's the first thing. So if this condition fails, the value of count should also become equals to 1. Value of count should be 1. So after setting it to 1, let's do our dry run again. We will start looping from the index 1 because we are checking I minus 1, right? So over here, the value of count is 1 because if one element is included, the count is going to be 1. Now, if the consecutive elements are not same, then the count is incremented. Okay. So when our index is over here, the I minus 1 is over here. Obviously, colors of I minus 1 and colors of I are not same. So the count becomes equals to 2. Now, when the value of I comes over here and I minus 1 is over here, right? Now, colors of I is again not equals to colors of I minus 1. Again, we will increment the count. So when the index I is over here, the count becomes equals to 3. And in case the value of k was 3, we would have simply said, yes, there exists an alternating subarray of size k. However, the value of k is not equals to 3. The value of k that we have got is equals to 6. So with this approach, we won't be able to find if there exists an array, if there exists an array with alternating colors of size 6, because over here you can find a maximum size of 3, and over here again you can find a maximum size of 3, but you're not able to find a maximum size of 6. To find that out, we need to iterate in a circular fashion. So we can find it out like this: 1 0 1 0 1 0. Yeah, this is going to be our 6 elements like this in a circular fashion. So how do we travel in our array so that we can travel in a circular fashion? So the question is, after taking in the last element, how many more elements do we need to include in? So if we have included 1, obviously we need an array of size 6. So we need k minus 1 more elements, right? So in this question over here, we need 5 more elements. So we need to iterate till 5 more elements. 5 more elements in this case is this: 1, 2, 3, 4, 5. So we need to iterate till here. Now this is going to be our index 6th, right? This is 7th, 8th, 9th, 10th, and 11th. So we need to go from 1 to n plus k minus 2. We need to iterate from 1 to n plus k minus 2. Now, obviously, if you see over here, we don't need to create a new array because these elements are repeating themselves, right? So again, we can just use the modulo in order to do our work. So in order to access the element at the index 7, I'll just do the index 7 modulo 7, which will throw me to the index 0, which is the same as this element, right? In order to access the 8th element, I'll simply do index 8 modulo the size of the array, which is 7. So I'll get back to this array again. We don't need to add this part of the array again. We just need to do the modulo. Okay. So our code will slightly change. Instead of going from 1 to n, I'll go to n plus k minus 2. And since we need to take in the modulo because otherwise we'll go outside the bounds of the array. I'm telling it again, I've not joined this separately. You can join that separately, but we need to have our code as optimal as possible. So I'm not joining this part to the array. What I'm doing is I'm just accessing it using the modulo in a circular fashion. So instead of writing I minus 1, I'll write I minus 1 modulo n. And similarly over here, it should be I modulo n. And thus, if the count becomes equals to k, we will say, yes, there exists an alternating subarray of size k. Now, I've just done this part of the question. To find out if there exists an alternating subarray of size k, the question is to count how many such alternating subarrays exist. Now, instead of saying yeah there exists, I'll just maintain a count of answers. We'll initialize our answer with 0. Obviously, the initial count is 0. And if we find out there exists an alternating subarray whose size is k, we'll just increment our answer, isn't it? And we need to adjust our count now because the count has now become equals to k. So the question is, what should we set our count to? After we have found an alternating subarray of size k, we increment the count of such arrays. Now we have to reset our count, right? Should we reset it back to 1 or should we reset to something else? That's the question. To find out the answer, let's just traverse our array. We start with the first index. When we start over here, we see that the consecutive elements are not same. It means they are alternating, so the count becomes equals to 2, isn't it? Now we move further ahead. When we come over here, the count becomes equals to 3, and when our iterator come over here, then we fall into the else statement because these two zeros become same and we don't fall under this condition. So the count becomes back equals to 1 again. Now when we come here, we fall under this condition again because the consecutive elements are not same. So the value of count becomes 2. Now when we come over here, then again we fall under this condition, the consecutive elements are not same. So the value of count becomes 3. And after that the value of count becomes 4, right? Now, when we move further ahead, the value of count becomes equals to 5. And similarly, the value of count becomes equals to 6, isn't it? The first time the value of count becomes equals to 6 is when we are including this part of the array. So when the value of count becomes equals to k, which means the value of count becomes equals to 6, we are incrementing the count of our alternating group. Okay. So when does this count become equals to 6 for the first time? So if we see over here, our count becomes equals to 6 for the first time when it is at this index over here. So our count is equals to k for the first time when we are including this part of the array and our index is over here, right? So obviously we are incrementing our answer. We found one such group when there are alternating colors and the size of that group is 6. Now when our iterator moves to the next element, we check k elements back. Are we getting an alternating color pattern? We check k elements back. So we check these 6 elements, right? We need to check only these 6 elements, isn't it? Now when our iterator is over here, we see, yes, we are getting another such array. Now if we set our count here as equals to 1 back again, then it won't work, because when our iterator will come over here, we will see the count is only becoming 2 while the count is actually 6, right? So what should we set our count to when our iterator comes over here? We know k minus 1 elements before it are following the alternate color patterns. So when we come at this index, then we already have the count of k minus 1 element that are following the pattern, k minus 1 elements before it. So it means these 5 elements before it, isn't it? So the count over here, it should be k minus 1. Yeah. So instead of setting the count back to 1 over here, we will set our count to k minus 1. Or we can simply do count equals to count minus 1, because the value of count is already k over here. So we'll set our count to count minus 1. Yeah. And that's how we are going to solve our question. Now let's move ahead and code it up. So let's start by storing the size of the array in a variable n. After that, we need to initialize our count with 1 and our answer is initialized with 0. Now we'll start looping through our array. And from where to where do we have to loop? I've told you this before. We have to start from 1 and we have to go till n plus k minus 2. So we will start looping in our array. Now, if consecutive elements are not same, then we will increment our count. And if the value of count becomes equals to k, we will increment our answer and we will set back our count to k minus 1. However, if consecutive elements are same, we will set our count back to 1 because there are no longer alternating colors. And finally, we are going to return our answer. Now let's run our code. So here we have forgotten a thing, like we are going till n plus k minus 2. So since it's a circular array, we have to take it modulo n. We have to make the size less than n. Don't forget to take the modulo sign. Now let's submit it. So that was our solution. Hope it helps.